Okay, so very sorry. On the last video, when going, when I'm going through these questions, my computer got stuck, cannot move the page. So I need to redo this question again. But let's take a look. This question we try to graph -3 tangent pi x. And I show you all the steps here, how to graph. Okay, so let me write down. We want to graph y equals to -3 tangent pi x. That's what we want. So I can make the page a little bigger so we can see better my work. Okay, so here a little smaller so I can see the whole thing. Okay, so first we need to graph the parent function. I graph the parent function. You need to memorize that. And I have some trick here for you to easier to graph. So say if we have the formula to calculate the new function, right? Our new function has the b equal to pi. So the period will be changed. So the new period will be original tangent x has a period pi. And then because the new function we have pi times x, so you need to divide by pi. And in the end, you have pi over pi equals to 1. So say this, for example, if you have a function, the period original is pi. Let me erase this one. So let me do an example for you. If you have a function, their period from 0 to pi, and then because you need to divide the value b is pi, so the new period is pi divided by pi. So in the end, your period will start from 0 goes to 1. In other words, all the number, all the angle here, all the angle in between, if you have pi over 2, pi over 4, or 3 pi over 4, for example, then the new graph will be all divided by pi. All divided by pi. So you have 0 here and 1 here, and this number become 1/4. This number become 1/2. This number becomes 3/4. So we can make the graph easier to do. Is originally you have pi over 2, and if you have b times 2, b times x, then all the number, all the angle here, you divide by pi, divide by pi, divide by pi. Okay, so when you divide by pi, follow the formula. You divide by pi, then the x coordinate become 1/2, 1/4, and the -1/2. That's the easier way you can graph. So without changing the graph, you may change the coordinate. So same thing, when you change the coordinates, same as you change the whole graph, because they are different graph already. Why they are different graph? Because they have different x. Now, after you have the new graph, then think about -3. -3, so we take out the negative. Negative means you want to reflect the graph left right. So you have a new graph, and then times 3 means you stretch both direction, right? Times 3. When you have infinity, times 3 is still infinity. Just this, right? Okay. And if you have any value like 1 here, for example, when you have pi over 4, when you have pi over 4, you have negative 1, 1, right? You have 1 here. Reciprocal 1 still 1. But when you multiply 3, is triple. So means when you have triple, means the y value grow faster. So the graph will look skinny. When someone grow faster means looks like you are skinnier. Okay, so the graph should look like skinnier. Okay, so this is the final graph, and we can check which one looks like the right graph. Yeah. So you can go back to choose. So how you choose the right graph? The shape of the graph is important, yes. The intersect is important, right? And the x value also important. You need to pay attention on all the numbers. And the asymptote also important. The asymptote. Okay? So you need to pay attention on everything detail. Okay, now it goes to number. Well, if my computer doesn't work fine here today, I have trouble to finish teaching. Okay, number 7. Perfect. Let me cut the topic. Okay. So right now we want to use the formula to help us. The shift is pi divided by 3. So the graph need to shift. Now I have some parents graph to help. So first you have sine function, and then you have cosecant function. And then when cosecant times 3, just grow. Sorry. Remember, when you have b equal to 3, you just divide by 3 here. Okay? Make a graph easier. Divide by 3 here for the x coordinate. Okay? And then you need to do the shift. Did I do the shift? Okay, keep going here. Okay. So after, okay, well, it's gone. Okay. So after we finish this one, then next one we need to do the shift. Shift basically is you want to shift to right hand side. The whole graph shift to right hand side pi over 3. In other words, all the number become plus pi over 3. All the number here plus pi over 3. Then you have a new x coordinate. So this you want to go home. Not only watch the video, you want to pay attention on the paperwork here and try to graph by hand, by yourself. So you will understand what I'm talking about. Okay, so this is kind of shortcut. for you to graph. You use the same graph, but you change the coordinate. You change x coordinate. Then you have a new graph. But when you change the new x coordinate, then you need to keep in mind the y axis will change the location because you have shifted. Now next we try number 8. Number 8. Start from number 8. It's not a graph, even though you see a lot of graph here, but not as hard as the question started from number 1 to number 7 is a hard graph. But the number 8 is a new type of question. Let me see. Okay. So cotangent means the reciprocal of tangent. And if you have a tangent, that means opposite over adjacent, if you remember that. So this opposite is 1. And adjacent is square root of 3 on the right triangle. So follow Pythagorean theory, you may calculate the hypotenuse. So once you have 3 sides of the right triangle, this is opposite, this is adjacent. Then what do they ask you to find? They ask you use a graphing utility. So you may use graphing calculator, but actually this question you don't need to. Okay. So by this way, you can see that sine x will equal to 1/2. When you have sine x equal to 1/2, if you remember, it need to be 30 degrees, or you say pi over 6. Okay. Now, they ask you to find more than one solutions because on the unit circle, you have 1/2 here. Also, you may have, okay. Now, we don't only pay attention on sine x equals to 1/2. Actually, you need to pay attention on our original given. The given question is talking about cotangent is positive. When cotangent is positive, means your opposite and adjacent either both positive or both negative. So either positive or negative. This is very important new skill you have to learn here. If they give you sine x, that's one story. But when they give you cotangent is positive, means opposite and adjacent need to be both positive or both negative. So you can have positive become positive. Negative also is positive. So then you can see that in one circle means in 2 pi. In 2 pi, you may find 2 angles satisfy this situation. One angle is pi over 6. How about the other angle? The other angle is pi plus pi over 6. So pi plus pi over 6. Okay. And then we may talk about how about they want to extend to the negative angle. So if you have a unit circle and you want to go to these two locations. So negative angle here. It's almost the pi, but not the pi yet. So this is pi over 6. So I will say pi, take away pi over 6 will be this angle. So, but it's the whole thing is negative, right? negative angle. So you have negative, and then the real value of this size, or we say absolute value of the angle, will be pi minus, you goes to pi and go back a little bit, pi minus pi over 6. This pi minus pi over 6 need to go to negative direction. So that's one more angle here. Then how it goes to this angle here is also negative, right? It's negative. And it's almost 2 pi. You go negative almost 2 pi, but not the 2 pi yet. You go back a little bit. So it's 2 pi take away pi over 6, and it's a negative. Okay. Or some students want to say, okay, can I do is negative 2 pi and the plus pi over 6? Yeah, you can do that. You go negative 2 pi and the plus pi over 6 back. Okay, you go negative pi and the plus pi over 6 back. So go this way, you go negative pi and the plus pi over 6 back. So depends on which one is easier for you to understand, you can do that way. Okay, now we do number 9. Number 9 is a similar question. So if you feel hard to understand number 8, we have more space to explain here. So cosecant is just the reciprocal of the sine function is opposite over hypotenuse. So hypotenuse no positive negative, it's always positive. So if cosecant is positive, then the sine value need to be positive. Now we have two positions, quadrant 1 and the quadrant 2. We both have positive sine value or positive cosecant value. Now you have two angles here. Okay. When you have when you have 1 and the square root of 2, do you remember this angle is pi over 4? Or we say this is a 45 degree. So these two numbers need to be the same. Okay. So this is one of the knowledge we proved earlier, and you want to memorize. This angle need to be pi over 4. So let me make the circle bigger. Pi over 4. And the other angle, you can do it pi and then minus pi over 4. So the other angle pi, take away pi over 4, will be this one, up to here. This is the x. Now, if we want to go to the negative direction, you have two angles here, and you want to go to negative. So I will say it's negative pi, and keep going negative more, negative pi over 4, right? Negative pi and plus negative pi over 4. This is negative pi and this negative pi over 4. So you can say negative pi and keep going one more, negative pi over 4. Okay. This angle here is negative. You want to go to negative 2 pi. Go this direction. Your direction goes to negative 2 pi. But this angle, when you go to negative 2 pi, you go too far, right? So go back. You plus back pi over 4. Or you want to say, okay, you have negative pi over 4, but not negative 2 pi, but not go so many angles. So you can use this way or this way. Depends on which one you feel easier to use. So this is number 9. And then it goes to number 10. So, okay, good. Number 10. Number 10 is a little easier because remember when we talk about the odd or even, we have the formula. If negative x input become negative, okay, if you have function, you input a negative and end up with the opposite of the y value, then we call it odd. If you have a function f of x and you input a negative x, there's no change, then we call this even. We learned that from chapter 1. Okay, so if this one doesn't equal to function x, if yes, then that's even, but it's equal to the opposite side of the function value, then this is odd. And the tangent, how do you know tangent of negative x will be negative tangent x? We can see that this is a tangent graph. Tangent graph is here. Okay. If you input a negative x, means this graph need to be flipped left right, right? Left right. And the left right, how it looks like. If I graph this one here. Okay, let me erase this one. Let me erase all the mark here. I can show you later. Then my computer not too good. How come? Okay. So let me graph this one here. This one, right? They are the same thing. Okay. How you feel? Do you feel like it's just upside down graph? Positive y become negative y. Negative y become positive y. So that's how we have the y value just the opposite of from the original tangent. Okay. So this is tangent negative x. And the tangent negative x happen to be the opposite of the tangent x. Therefore, we say this is opposite of tangent x. So you say f of x equals to f of negative x, this negative x, equal to negative fx, which is the odd, the definition of the odd. And the number 11, you want to check if this is a even function or not. So same thing, you just algebraically, you input the negative x to the function, and then simplify. Negative x squared still x squared, right? And then negative x. Now, how do you know secant negative x will equals to secant positive x? How do you know that? Okay, keep in mind secant x is the reciprocal of cosine x. So if the cosine x equals to cosine negative x, if that, then they will be the same thing, right? If you have, they are the same sign. Now cosine is talking about adjacent, remember? So no matter you have positive angle or you have negative angle, they still share the same adjacent. So no matter you have positive angle or negative angle, cosine value are all the same. You can see it from this graph. Okay. Now we go to number 12. Very good. Now number 12, we have two functions. They tell you the function expression. And because I already learned more than you guys, so I know these two are equal. I know that, but you don't know yet, right? So that's okay. We just try to graph. I think I would suggest you use graphing calculator to graph because too much work. But it's better you can graph by hand. It's very complicated. But you need to distribute 1/2, take a 1/2 cosine 2x. So this is g of x. Okay. So this will be d. And then this will be a. This will be b. And the plus 0. This is c. So you are able to graph by hand. And now, first, I want to teach you how to graph sine square. Remember the sine function, symbol, that's one period of sine function. And if you want to make a square, what square means? Means negative become positive. Square, the value will be 1, that's 1, right? 1 still 1. And then square, the fraction square, right? So 1 still 1, and it will be something like that, right? Okay. Because the fraction, like 1/2 become 1/4, is smaller. But 1 still 1. You need to keep in mind of that. And then same thing here, but repeat. Why is repeat? Because square make a negative become positive. Okay. So at least, I will say at least, you have a sine square function here. You have sine square function here. Okay. And if we really need to graph by hand, that's a lot of work. Let me see. No shifting, no shift, but need to push up 1/2. But when you push up 1/2, here you have times 1/2. I don't see any shortcut. Or you already done. They are equal. I upload a list of the formula. You can find this sine square s equals 1/2 1 minus cosine 2x. You may find this formula, but I have not teach you this formula yet, so you don't supposed to use that. Okay, I'm tired of graph this one for you because it's not beyond your ability right now. So I would like you to graph by yourself. Okay, for g of the function g, you graph by yourself, and hopefully you can find. Okay, so it's not this one. It's this one, right? Sorry, that's wrong. That's wrong. Oh, okay, it's this one. Okay, so the sine function disappear again. Sine function. Oh, it's nice. Okay, I can do this way. Now I see. I can. Okay, easier. Wow, really bother me. this computer today. Okay, sorry about that. Sine square is here. Let me redo this one. Sine square here. This one. And the g of x, I will let you graph by yourself. Supposed to be the same. Okay. And then we go to next one. Oh, I know how to do this one easy. Okay, I see. So actually the function, these two functions are equal. F equals to G. Okay. Now let's try number 13. Number 13 is kind of interesting. Number 13. When you have two functions multiplied together, okay. So first you have to think about that. E of negative x, negative 2x. This function is the exponential function, right? Exponential function we may have. Okay, I try to teach you to graph by hand, but actually we don't do that because probably beyond your ability to understand. The instructions say use a calculator to graph. So you just use calculator. Okay, you input y equal e to the negative 2x and then multiply cosine and then input the x. You should see the graph. That's easier this way, okay? If you want to learn how to graph by hand, it's really fun. You talk to me, I try to teach you, okay? So the basic idea is because the cosine function is between 1 and the negative 1, and then after you multiply this value, this exponential function, the whole function graph will be bounded inside. So that's very interesting. But anyway, I will let you try to use the graphing calculator. So when x become infinity, what happens? Y value become 0? Looks like, right? It's 0. Number 14. Number 14 is not too hard, but it's the word problem. They give you two functions, h here and this one here. Okay, and you can see the gap because they are talking about the difference. In the end, they are going to talk about the difference. So the difference is changing. Okay, the difference means the y value subtract. So the y value of the h take away the y value of the error. So you can see the y value is kind of changing. The gap here sometimes smaller, sometimes bigger here. So this is the biggest gap. Okay, you can see that. Which one is bigger? This one is bigger. Okay, so I suddenly talk about part B first. Okay, so part A. What is the period? You can see that the sine function, cosine and the sine function. Cosine sine function, they are both 2 pi. So even though they have plus minus, the period is still 2 pi. Okay. So when you have sine function and the cosine function, the period is 2 pi to repeat itself. after you plus minus, they still have 2 pi. So, but why the answer is not 2 pi? Because, do you see that? Pi over 6. So if you follow the formula, if there's no, if b, because the b is pi over 6, so the formula for calculate the new period will be the original without pi over 6. The original sine function, the period is 2 pi. But because we have pi over 6 to multiply, so you divide by pi over 6, follow the formula. Therefore, p equals to 2 pi times 6 over pi, and you reduce, p is 12. So both functions, they have the period is 12 months. So this is not too hard. And then part B, they ask you to find the difference between the normal high and the normal low. This is normal high, and this is normal low. Okay. I remember the first. I remember the question say more. Let me see. During what part of the year is the difference between normal high and the normal, or the greatest? Yes. Okay. So when the difference is greatest, so this normal high, this normal low, and basically they are talking about what's the y value. The difference of the y value is greatest. Then looks like where it is. Looks like, okay, they don't ask you for the detail. So spring, where is spring? Spring is here, yes, I guess so. And where is spring? Spring, no, sorry, spring is this winter. Spring is here, 4, 5, 6? No. Oh my God, I don't remember what is spring. Spring is 3, 4, 5? I remember is spring is 3, 4, 5. This is about spring, okay? This is about the summer. This is about the fall, right? And then this, I guess, according to I remember that. Okay, you can double check by yourself. So the biggest difference will be in the summer. Did I say the summer? When is summer? Summer start from what? So definitely, this is summer, right? July. June is summer or spring? I'm not sure. So probably this summer. Anyway, this is summer. Okay. What is the least? The smallest gap here. I'm sure this is winter. Okay. Sorry about the summer. The definition for summer, spring. Okay. So anyway, you find out by yourself. So I'm done with 4.6, and the next, starting from 4.7, 4.8, we are going to learn something a little different, more calculating. So before we keep going to 4.7, please study 4.6 first. Finish study 4.6, and when you are done with 4.6, then we start 4.7. And I feel very sorry for today's class because my computer screen kind of hard to move, so I don't know if I teach well, you can understand well enough or not. If not, ask me question during the class time. Okay. So see you next time. Bye bye.